Hi everyone, I'm Ayaka Smart. I'm a current rising sophomore at Emory University, and this summer I was based in Pullman working on climate analogs. So the question is, what are climate analogs? Well, climate analogs are a way to describe the future conditions in a target location within the context of current experiences in a different location, or the analog. For example, parts of Washington state in the mid 21st century could resemble climatic conditions in current day California. So what I was working on specifically were climate analogs for specialty crop counties in the lower 48 United States with a mid 21st century time frame, so roughly 2040 to 2070. Moreover, we were working specifically with RCP 8.5, which is one possible scenario of greenhouse gas levels on Earth. So this would mean no change in climate change policy and more extreme consequences in that time frame. So the benefit of using climate analogs is that they create a more tangible portrayal of climate change. Moreover, finding these target analog pairs is an excellent climate change communication tool because they allow the target location to gain insight around the kind of crops that can be grown in an altered future state, or how they might be managed differently by leveraging the actual experiences in the analog location. The caveat being, we need to find the right pairs for meaningful dialogue. Moreover, climate analogs can provide wonderful insight into water intelligence. Agricultural water usage accounts for 70% of global freshwater withdrawals. And however, this water usage is highly crop dependent. But with climate change, that crop mix grown in a region can become drastically different, and crops that are suitable in different climatic conditions can be predicted through climate analogs. So the goals of this research were, like I mentioned, looking for the future in current conditions. Moreover, determining analog differences and their implications. So making sure that we have the best pairs in communication with each other when facilitating those dialogues. Finally, one of the goals is to use machine learning approaches to find the similarities. So understanding that statistical machine learning element and applying that to the climate analogs. So a question that I was working on specifically is there value in estimating context specific variables? But what does that mean? So it's important to understand that majority of the existing work on agricultural climate analogs is based on raw temperature and precipitation variables. However, we know that these variables translate to an agricultural context in a nonlinear way, such as factors like growing degree days, product season length, heat degree hours, and so on. And we calculated acceptable analogs for each crop county based on these two sets of variables. So like I mentioned, the first is just a simple temperature variable measure, which is 4 measures of seasonal average temperature. The second is the table shown on the left, so crop product relevant variables. So the question that arises then is, do these nonlinear translations of climatic variables into variables of interest result in similar sets of analogs? Or is there value in estimating context-specific variables? So the process behind this was a little more complex than I had initially expected it would be, but it ended up being a really wonderful experience. So I had to become familiar with complex scripting and approaching and learning high performance computing from my interdisciplinary perspective. So coming from an environmental science and agricultural background, becoming familiar with this high performance computing and different interfaces for coding and things like that. Also becoming familiar with machine learning distance metrics, so things that I had never heard of before, like Mahalanobis distance, and understanding those and being able to apply them to climate analog work. So what did we find? Well, we found that the majority of US specialty crop counties have some acceptable analog in other specialty crop counties, but most counties in the United States have no commonality in the analog set when you use raw climate variables versus the agricultural specific derived variables. As we can see here in this table, or in this visual, most of the regions in the West have zero agreement rate between the two analog sets. So what does this mean? Well, this means moving forward, the community should use agricultural specific variables to connect the right stakeholders in communication. And the next steps for our process specifically? Well, it's continuing to ask why and figure out the difference between the linear and nonlinear analogs. So find out why these two are different. Moreover, working to continue having these dialogues around based on climate analogs to improve not only water intelligence, but agricultural climate adaptation as well. Are there any questions on anything that I've mentioned so far?